we're now going to do addition and subtraction of radicals. And radicals just are like terms. So for example, in algebra, if we said 4x plus 3x, the x's were like terms. We had 4 of them plus 3 of them, so that told us there were 7x. And this really came from the fact that 4x plus 3x, we can factor out the x, and we're left with 4 plus 3, which gave us 7x. With radicals, we're going to do the same thing. We're going to have to add what are called like radicals. And what we're doing is we're combining like terms, so the radicals have to be exactly the same to be added or subtracted. So as an example, I might say simplify 4 radical 2 plus 3 radical 2. I'm really talking about like terms. They're both radical 2's. So 4 radical 2 plus 3 radical 2 would be 7 radical 2. But if I said simplify 4 radical 2 plus 3 radical 5, they are not identical radicals. We're talking about I have 4 radical 2's. It's the 2 stuck in jail, and that's different from 3 radical 5's, the 5 stuck in jail. This is like saying 4x plus 3y. They aren't the same terms. So in this case, 4 radical 2 plus 3 radical 5 would just stay the same. It would just stay as 4 radical 2 plus 3 radical 5. It could not be combined. The difficulty comes when we are given to, for example, if I said simplify and combine like radicals, and we have radical terms that don't look the same, but really what's hiding is the same radical. So an example might be if I said 3 radical 50 minus 2 radical 72 plus 5 radical 18. Looking at this, they're not the same, but I can see and hear that square root of 50 is square root of 25 times square root of 2. And then we have 2 square root of 72 is square root of 36 times square root of 2. And then 5 times square root of 18 is square root of 9 times square root of 2. I did this without prime factors because these are very recognizable. The square root of 25 we know is just a 5. The square root of 36 is just a 6. The square root of 9 is just a 3. So this becomes 3 times 5. The 5 is outside the radical, so it's 15 radical 2 minus 2 times 6, 12 radical 2 plus 5 times 3, 15 radical 2. A problem that started with different radicals, when simplified, they all became radical 2. So we have 15 minus 12 is 3 radical 2 plus 15 radical 2 is, the answer is 18 radical 2. So for this one, we're always going to be simplifying first and then looking to see if we have the identical radical. And then we combine like radicals. We'll do a last one that involves variables. So suppose I said to simplify and combine like terms. In this case, there'll be like radicals. Here's one that involves variables. The fourth root of 32x to the fifth y fourth plus 3xy times the fourth root of 2x. We can see the fourth roots have different expressions under it. So our first step is we are going to simplify. Working this on the side, I have to get the prime factors. That's what we always do when we see the word simplify. So I have 32 2 goes into that 16, 2 goes into that 8, 2 goes into that 4, 2 goes into that 2, and we are finished with a 1. So I've got 1, 2, 3, 4, 5 2's. So I can rewrite this as 4th root of 1, 2, 3, 4, 5 2's. We've got 5 x's and 4 y's being all multiplied. In doing this work, I can see that the 2 will come out. I've got the x coming out. I've got the y coming out. And I'm left underneath this 4th radical with a 2 and an x. This allows me to now rewrite this as the problem 2xy 4th root of 2x plus 3xy 4th root of 2x. They are like radicals. You can think of it as factoring it out. In any case, in working this, I have 2xy of these plus 3xy. The answer will be 5xy 4th root of 2x.